There, this is Iris, and in this presentation we're going to see iteration, iterators and iterables. You see, lots of people are getting confused and believe that, for instance, an iterator has also to be an iterable, which is not true. We'll see this as an example. Well, first let's start with what an iteration is. Iteration is just a process, as a general term, is for taking each item one after another of something. Now, let's go through Python and try to clear up these things. Let's make a list first. A equals 1, 2, 3, and 4. If you don't know what a list is, you can see it as an array, but there are two main differences. The first one is that each element can be of different data types, don't have to be of the same data type as here. And the second is that its size is increased and decreased by itself as you insert or remove elements. So A is a list. Now, what about iterators? Let's start with the iterator. If you want to create an iterator, you have to run the function iter. So by calling iter A, we have a new iterator, and this is B. You can check it by writing type A, it's a list. Meanwhile, type B is a list iterator. Okay, and what can you do with the iterator? Just one thing. To call it with the function next. Next B returns you the first argument, 1. If you recall it, if you call it again, you'll have 2, and then 3, and so on. Now, pay attention on something, it's very important. B has a memory. It knows, the same object knows what element will supply to us on its next calling function. So, if I'll call it again, it will give us 4. And what about now? Well, since it has been exhausted, it will return stop iteration exception. It's a quite essential exception, quite important, and we're going to have a short discussion a bit later on. Now, so an iterator is just an object with memory. It keeps tracks. It knows what will supply to us on the next calling function. Now, what an iterable is? To answer that, we have first to specify the data types Python has. There are two kinds of data types. There are atomic data types such as integers, floats, or booleans, for instance. And on the other hand, we have collection data types such as lists, we've already seen, tuples, dictionaries, and sets, strings, whatever. Well, strings, by the way, is a collection data type as it's a sequence of characters. Now, atomic data types are integers, floats, as we said, but you can't have any part of them, you can't slice them in any meaning. So that's why they're called atomic data type. They're not iterables. On the other hand, all the collection data types are iterables. So for example, if you say, iter of 4, which is an integer, you have a type error. Integer is an object that is not iterable. On the other hand, if you say iter of a string, you have that it's a string iterator. That's perfect, that's normal. Now, also iterable, you can make your own iterables, not only the predefined by Python. And we'll make one in a minute. Now, so iterable is any object that you can actually use the iter function, and the iter function always returns an iterator. Now let's start with an iterator. Let's make our own iterator, and in this case we'll separate the iterable by the iterator. Let's make first the iterator. Now, in this example, we're gonna make, let's say that we want an iterable object, and an iterator, of course, that will return us values from 0 up to a number we will supply. For instance, it will say that we want to iterate through up to 4, it will give us the values 1, 2, 3, 0, 1, 2, 3. It's similar to the range function in Python 2. You see, in Python 3 the range function is not based on iterators but in generators. Okay, so we have the iterator. We first have to initially we have to dunder init function method. The dunder init method is always executed every time you instantiate an object, you create a new object. The first argument always is the object's name. We use the variable term self. It's not prerequisite, it's not mandatory here. You can use anything you want to, but you just keep it as self, like in Java. Self n equals n means that our object will store the value we're going to go through. Meanwhile, as you may remember, we say that it's an object with memory, so it will always start from 0 and goes increased by 1 up to the value of n. So we need another variable, self n, another attribute, which is the memory value. This will be used for the memory of the iterator. Now, as an iterator, we have to develop the dunder next method. Each time you call next, what is next b, for instance, what is called actually is b dot dunder next. This is the method makes all the job, all the heavy job. It first has to do if there are more elements to supply. So if self I is less than self n, we haven't reached the maximum value yet, we have to supply the next one. Well, meanwhile, it has to be prepared, self I, to go on to the next value. So we can't do this on the same line, so we first store it in a temporary value. Temporary value TMP equals to self I. Now we can increase self I by 1, and now we can return the temporary value we already have. Now, at this point, a lot of people would write else. We don't need an else statement here. You see, it's an if, and it's in the last line we say return, which means that if we go through this, it doesn't need an else statement. We just raise an exception if, in case that the condition in the if statement is not true, and the exception, as we've already seen, is stop iteration. And that's all we had to do to implement the iterator. Now let's implement the iterable object. Of course, we have also the dunder init method. We'll store again in a self n value attribute the value of n, and we only have to develop the dunder iter method. The dunder iter method, the dunder iter method is called every time you say iter. Every time you use the function iter, it calls the dunder iter method of this specific object you have as an argument. And it always returns an iterator. In our case, is iterator 1. And its argument, since it needs an argument to instantiate it, it will be also self n. And that's the basic iterable object. Now let's go through this and see how it works. Iterable 1 will create this function call with the argument 4, will return us a new object. Now, if you want to build the iterator, you use the function iter. The function iter will call the dunder iter function method already developed in iterable 1. And if you use the b, the iterator, you need next b. And again. And another one. Now let's have a line for the rest. Let's save it and see how it works. I don't have any mistake. We'll see this. Okay, so you see the first elements 0, 1, 2, and things are going on as you use the function next. That's perfect up to now. Now let's try to combine those two classes and make a single class that be at the same time iterable and iterator. This is many people, this is what we usually do actually, and that's why the reason that a lot of people are getting confused and they believe that it always has to be like that. No, it doesn't. I'll copy and paste. I don't want to go write all this again, of course. And here it will be iterable 2. Iterable 2 has a dunder init method that also has, as an iterator as well, needs a self I value variable for the memory things. We don't need here this one, and also has a dunder init iter method, but doesn't return now something else. It returns just itself, since it's the same object, also iterable and iterator. And if you want to try this, let's do that. Paste and rename the variables A2, B2, iterable 2, A2, B2, B2, B2. Save it and run it. And as you see, the results are the same. But now we have it in the same class. Now, what about something more? Let's try to, you try to print the list of the remaining of the list B2. You'll see that you have the remaining elements, which is just one element, 3. And if you call this again, you'll see that you have as a response an empty list. And why is that? Because it has been exhausted. B2 has nothing more to give us, cannot give us anything more. So many people, not quite often, depends, you may want to reinstantiate it each time you call it. You can do that by changing the iter function, and let's make a new one. The third one, iterable 3. Iterable 3 has its purpose to supply to us all the elements, it has all the arguments from this first one, each time we call it. And you can do this by reinstantiate the self-I method, the attribute, sorry. And let's go on through this, copy, paste, but now let's say A3, iterable 3. I think I changed it here, yeah, okay. B3, A3, B3, 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 and the lists that will be identical actually. And here we are. On the second case we were here where we had 3 and the empty list, and now we have each time we call this iter function restarts from the beginning. It's a new iterator. Now that's about iterators and iterables. I think that you've already can separate them. We can see, you can distinguish the difference between them. You can see the reason that we combine them quite often. However, let's say you have to know that in Python 3 it's not much of use, since it has been replaced, they have been replaced by generators. It's more convenient, especially if you have lots of elements or strings or something. Now, something else we have to say, that what about the stop iteration? Well, lots of people said, why not to return an element, something, a value such as none or \n we have in strings or whatever. Well, they are objects as well, and if you wanted to iterate through them, you couldn't. That's why it has to raise an exception, and that's why you have the stop iteration exception. Well, I think that's all we had to say. So be well. Thank you very much.